We'll now be looking at the cosine rule. So over here, use the triangle below to prove the cosine rule. So once again, we are going to construct this line perpendicular to the base, and we're going to call it a height of h, or h. And then we are going to call this point over here d. What we're also going to put in is we're going to say that this is x, and if this is x, if this whole thing is a, then this being x makes what's left here a minus x, or the whole length of a taken and subtracted by x. Alright, so here where we've previously applied sine rule in both triangles, now we're going to start off and apply Pythagoras in both triangles. So we're going to start off by saying in triangle, we've got ACD, so ACD, we have for Pythagoras, we'll say that b squared is equal to x squared plus h squared. Right, and then to do the same in the second triangle, we'll say that in triangle ABD, so ABD, we have for Pythagoras, we've got c squared equals to this h squared plus by a minus x squared. Okay, so what we're going to do now is just to multiply this out. So I'm just going to go with a quick way. So this is going to be square the first number. So this is a squared multiply by 2, multiply by each other, multiply by 2 minus 2ax and plus x squared. So in this, once we're here, we can see that if I just rearrange this, there's an h squared and an x squared like we see at here. So to rearrange it, I'm just going to write x squared plus h squared, and then these two terms is plus a squared minus 2ax. So this I'm going to replace with b squared. So this is going to be b squared plus a squared minus 2ax. All right, and now since we're using the cosine rule, we're going to apply the cosine rule, or actually not the cosine rule, just going to apply cos, which is adjacent over hypotenuse, to this triangle over here. So also in triangle, so once again, in triangle ACD, we have cos of c. So cos of c is equal to adjacent over hypotenuse, so that gives us x over b. And then to solve for x, I'm just going to take the b up. So let me just rewrite it like this, equals to cos c. So taking b up will then be x is equal to b cos of c. And then I can, so I've worked up to here. Now I'm just going to replace this x over here. I'm going to replace with that. And I'm just going to write this as a squared plus b squared instead of b squared plus a squared. So this then becomes, therefore, we've got c squared is equal to a squared plus b squared, which is just these two, minus 2a, and then instead of this x over here, I'm going to replace it with b cos c. So b cos c. And then we've proved one of the three cosine rules. So therefore, similarly, we can just now finish up by saying similarly, it can be shown. And then we just end up by writing the last two. So over here, we'll just, or over here, we'll just write that a squared is equal to b squared plus c squared minus 2bc cos of a, or the other one was b squared is equal to a squared plus b squared minus 2ab cos of b. Okay, and then to do some calculations, we need to calculate b. So here we see we've got two sides with a included angle, and that's always a first indication of to use the cosine rule. And to find b, I'm just simply going to write out the rule first. I've got b squared is equal to a squared plus c squared minus 2ac cos of b. And then what I'm going to do is to substitute in my values. So in one go, I'm just going to say that b on its own is equal to the square root, because I'm just taking the square root immediately and substituting in the values. So a is then equal to 5, so 5 squared, plus c, which is 6 squared, minus 2, so that's 5. Instead of c, I got 6 cos of b. B is 63 degrees, and then just square root all of this. So I'm just going to say in the calculator, I'm square rooting it, and then we've got 5 squared plus 6, got 6 squared, minus 2. Now actually I'm going to put a bracket here. So what I'm going to do is I'm just going to put a bracket around all of this. So I've got 2 times by 5 times by 6 times by cos of 63. I close my small brackets and then I close the big bracket that I put in. So this gives me 5,81. So 5,81. Okay, and then we want to find this angle. So there's another indication to use the cosine rule if you have only 3 known sides. Then we're going to we can find any of these angles. And in our case, we want to find angle G. So what we're going to do is we're going to start with the small g. Since we want to find the angle cos or find G, we need cos G to be in the formula. So G squared is equal to, then we have this h squared plus I squared minus 2hi ih cos of G. Okay, now what I'm going to do is just going to, in terms of the other variables, I'm going to solve for cos G. So to do that, since this is a negative over here, I'm just going to take this entire term, I'm going to take to that side, and I'm going to take this G and bring it this side. So this then, because this is a minus, it's going to go over and it's just going to become a plus. So hi cos G equals to h squared plus I squared minus the G squared, since the sign changes. Now I need to isolate cos of G, and to do that I'm going to divide both sides with this 2hi. So divide by 2hi. So what I have left is cos G is equal to h squared plus I squared minus G squared over 2hi. And then I can, to find the angle on its own, I can say that the angle of G will be the inverse of cos, or the shift cos, of h squared plus I squared minus G squared over 2hi. And then substitute my values. So we have the inverse of cos, and then h is 6, so that's 6 squared, plus I is 4 squared, minus G, which is 5 squared, all over 2 times h, which was 6, and then I 4, and then that's what we put into the calculator. So just to be brief, okay, so that's shift inverse of cos, and then we have our fraction. So I know 6 squared is just 36 plus 4, which is 16, 4 squared is 16, minus 5 squared is 25, then 2 times 6 times 4. And we close the bracket, and this gives us 55,77. So 55,77.